Welcome and thank you for always joining us. We are presenting a question that was done in K.c.s.e 1990 paper 2 question number 11, a question on integration and its applications. And the question we have reads the gradient of a curve at any point represented by xy is 3x squared. Given that the curve passes through the point -2, 3, find its equation. Remember, the equation is in form of y, and for us to move from dy over dx, which is what has been given, we have to integrate the given function. In this case, we are going to have our dy over dx first, and the dy over dx has been given to be 3x squared, meaning for us to get y, we are simply going to integrate the given function, which is 3x squared, and we are going to integrate this in respect to the dx. Now for us to have y, we are going to have 3x squared. We usually add 1 to the power, then divide by the total new power, which is 3, meaning 3 and 3 will cancel, leaving us with x squared plus 1, which is x cubed, plus of course c, which is a constant of integration. Once we have gotten that equation, this is a general equation, and for us to get a specific equation, we need to get the value of c. Remember, we have been given the point -2, 3. -2 is the x coordinate and 3 is the y coordinate, so we are going to replace them here. For y, we are going to place 3 being equal to x is -2 cubed plus c. That means 3 will be equal to -2 power 3 will give us -8 plus c. If we move -8 to the other side, the value of c is going to be 3 plus 8, which will give us 11. That means therefore the equation will be equal to x cubed plus c, and the value of c is 11, and that gives us the solution to this particular question. Remember to subscribe and also help us to share the link. We are moving to the next question, a question that was done in K.c.s.e 1991 paper 1, question number 14. The question says evaluate, and we have been given the integral value. The sign here is for integration, and we are supposed to integrate 2x plus 3 and within the limit 3 -1. So in this case, we are going to have 2x. Remember, x is raised to the power of 1. We add 1 to the power, then divide by the total new power, which is 2, plus of course 3, we introduce x, plus c, which is a constant of integration. 2 and 2 will cancel, meaning we are going to remain with x squared plus 3x plus c. Then we introduce the limits, that is 3 -1. So in this case, we are going now to substitute the value of x, which is maximum. We substitute the minimum value of x, then we subtract the 2 for us to get the value of this particular question. So the maximum value of x is 3. So 3 is cubed plus 3 times x, x is 3, plus of course c, minus, we are going to have the value of x, which is -1. This -1 is squared, plus, sorry, this one is squared, plus 3 times x, which is -1, plus of course c. Remember, c and c will cancel because c minus c will give you a 0, meaning 3 squared will give us 9. 9 plus 9 will give us 18. Then this other side, we are going to have negative 1 squared, which is negative 1, plus negative 1 squared is positive 1, plus 3 positive times negative 1 will give us minus 3 plus c. This means 1 plus minus 3 will give us minus 2. Remember, already c is gone, so we are going to have a minus 2 here. Meaning now to get the true value of this evaluation, we take the first bracket, which is 18, minus the second bracket has given us negative 2, minus minus will give us a plus, and therefore this is 18 plus 2, giving us 20, and that becomes the answer to that particular question. We are now moving to another question, a question that was done in K.c.s.e 1992, paper 2, question number 12, a question on integration. The velocity v meters per second of a particle moving along a straight line at any time t seconds is given by v is equals to 3t minus 2. Its distance x meters at the time t is equals to 0 is equal to 2. Calculate x when t is equal to 4. The first thing we are going to do is to get the displacement function by integrating the given function for velocity. So we are going to have 3 t, this is raised to power 1. We are going to add 1 to the power, then we divide by the total new power, minus 2, we introduce t, then we add a constant of integration. At this point, s will be equal to 3 over 2 t squared minus 2t plus, of course, c. We are being told that its distance x meters at the time t is equals to 0 is equal to 2. That means s will be equal to 2 when t is equals to 0, meaning for us to get c, we are going to replace s with 2, and this one is going to be 3 over 2. We multiply by t, which is 0 squared, minus 2 times t, which is 0 plus c, meaning the value of c is going to be equal to 2. And for us now to have the specific equation, we are going to write the equation as follows. That is, displacement is equals to 3 over 2 t squared minus 2t plus c, and the value of c is equals to 2. They want the value of x, which is distance. Remember, the distance is the same as displacement, and in this case displacement is equals to x, which is going to be equal to, so we have been told at t is equals to 4 seconds, then our x is going to be 3 over 2 multiplied by t, which is 4 squared minus 2 into t is 4 plus, of course, 2. Remember, 3 over 2 times 4 squared. 4 squared is 16. 16 divided by 2, you get 8. 8 times 3, you get 24. Then minus 2 times 4 will give us 8 plus 2. Remember, 24 plus 2 will give us 26. 26 minus 8 will give us 18 meters as the value of x when the time is 4 seconds. That is the solution to that particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. For any question, support, or online classes, contact us through 0701 686 283. Thank you and welcome.